Every object in the universe exerts on each other an attraction proportional to their mass and which increases if they come closer. This is called gravity. Following Isaac Newton, Pierre-Simon Laplace attempted to model gravity as some kind of radiation field or fluid, and since the 9th century, explanations for gravity have usually been thought in terms of a field model rather than a point attraction. According to the universal Newton's rule, all the objects in the universe attract each other. So if we jump in the air, we invariably fall. It's that force of attraction of the earth called gravity that brings us back to the ground. If this force did not exist, we will continue to get high in the sky until we reach the interplanetary space. Since we were born and we're able to recognize things, we have seen the moon in our night sky, but it doesn't move from its place. So one question lurks from behind our heads when we were kids and look at the moon at night. Why doesn't the moon fall on Earth? Of course, it's not magic, it's science. We have to know that the gravitational force between Earth and the moon is strong, but the force is not strong enough to pull the moon towards us, as an apple falling from the tree due to gravity. Without having the force of gravity from Earth, moon would have just floated away from us. The moon's velocity and distance from Earth allow it to make a perfect balance between fall and escape. If the velocity of rotation of the moon was a little bit faster, it would have escaped the Earth's gravity. In fact, if it's a little bit slower, it would have fallen on Earth. That's why the moon doesn't fall on Earth. Now let's see together the difference between mass and weight. Our weight, which holds us to the ground and brings us back to the ground, is proportional to gravity. The weaker it is, the less we feel it. If we were in space outside the Earth's field of attraction, the feeling of gravity will totally disappear. However, our mass, in other words, the amount of matter, would not have changed, so we can say that the weight of an object depends on its mass. For example, an elephant has a greater mass than a mouse, and therefore it undergoes a greater force of gravity. That's why the elephant weighs more than the mouse.